Well, welcome everybody. It's great to have you here back at Emerald Hill Skies. It's been some time. I had a big convention I had to attend. I was out of town for a weekend or two. I also picked up a cold in my throat and had laryngitis for a week or two. But we're through all that now and glad to be back with you here on the fourth edition of working through Stephen James O'Meara's book, The Secret Deep. And as you know, we use a RASA 11-inch, and it's here in this Pier-Tech Tele-Station 2 observatory atop that adjustable height frame, also by Pier-Tech. And we're using a 2600, a ZWO ASI2600MC Pro camera with a little rig rack at the bottom with a lot of the electrical equipment, a little outrigger on top with a ZWO ASI178. It allows us to show you these sky cam pictures, and you can see right now where the telescope is aiming. We're here in the observatory, so to speak. Actually, the observatory is out there in the cold, about 200 feet away, and we're in here in the nice warmth inside my office. But I'm happy to tell you that we're already set on a couple of really interesting images. This is NGC 7510. It's an open cluster, and it's located in Cepheus. And the cool thing about it is when you center on NGC 7510, which is in secret deep parlance, it's secret deep object 107. When you center on 107, you get 108 over here to the right, and you also get another little object here. We can swing over to our planetarium software, Stellarium. You can see that our RASA is aimed right here on this little open cluster that's sometimes called the Dormouse cluster. And you can see over here that you get the Northern Lagoon Nebula, NGC 7538, and LBN. It's a hydrogen alpha 2 region, all in the same frame. So it's kind of cool to be able to see that tonight. You can see it represented here. We'll go ahead and take that image annotation off and zoom in a little bit on that cluster. Now, this is the live view. This is looking live through our Celestron Roe Ackerman Schmidt 11-inch telescope. And we can establish our new dark black level right there. Let's bring down our greens. You can see this is real live. This is looking through the telescope live. We're actually able to do the color matching live. Let's do another color balance and try to make some sense out of this. Try to dial down our greens a little bit. There we go. And we'll put our blacks right underneath that and bump up our mids a little bit. Still a little too much green there, isn't there? Kind of a funny way to blend all these colors, isn't it? Way too much green. Let's just do this manually because it is not working out to use our automatic color matching there, is it? Let's bring our mids back here. And if you look down here at the bottom where these vertical sliders are, look at the way this red peak is right here. So let's bring the green up until we get it a little closer to where the red is there. Now let's bring the blue down. What we're trying to do is kind of manually line up those peaks since our automatic color balance is not doing it very well. That's a little better, isn't it? And let's again line up our black level right underneath that and then bring this mid-level up so we can start seeing a little more of those hydrogen areas. That's a little too much, isn't it? A little too much. There we go. Now there's the cluster. And let's just hover on that for a second and see what Stephen James O'Meara said about that. Let me see if I can get you guys here and make sure our audio is okay. Yeah. And let me just see who we got there. There's Mike, welcome. And Azray, good to have you. Pier-Tech, good to have you. Vito. Kevin, great to have you here. Kevin, glad you're able to make it. Papa Tech, it has been a while, too long. Good to have you on from Florida. And Larry, good to have you aboard from Peoria, Arizona. Ricky, good to have you aboard from Florida. Welcome, you guys. So this dormouse cluster, NGC 7510, Stephen James O'Meara says NGC 7538 is real close. He talks about NGC 7538 first. I guess we'll slide over here and find that. NGC 75, there we go. Boy, that is just all over here, isn't it? Why are we having such weird color matching tonight? But anyway, there's our hydrogen alpha area. We'll dial down the reds just a little bit maybe. I don't know. There we go. It's a shell structure that appears to be a cavity at the edge of the surrounding molecular cloud. The cavity is well defined in most directions except toward the north. Yeah, there you can see we're experiencing the same thing. South and west, researchers have found several ionization fronts. It may be a region where successive generations of stars have been formed as a result of the shocking from ionized gas expanding from its central primeval yet massive O-type star. So you can see a powerful star there in the middle of it. The optical nebula we enjoy in our backyard telescopes is the most evolved section. In the infrared, there are several other younger objects, and he talks about that a little deeper. Wow, a lot about 7538 and the studies they've done. I guess 7510 is that dormouse cluster that we were looking at a while ago. And it's over here more in the middle and down. And Stephen James O'Meara writes that it's a bubble, it's part of a bubble of gas, which itself is a part of a bubble of gas around 5 degrees across. It's remains of the cluster's natal cocoon, which has been blown away by the cluster's hot young stars. So this used to be a nebula as well. You can see some kind of nebulosity sort of forming around some of these stars. It's kind of hard to see that visually, but you can see the way it's kind of shaping around our, let me pull some of the mids off. See how some of those stars are a little bit, I guess they're a little bit like cloudy around them, a little bit of a molecular cloud of some kind around them. And those clouds, that's what he's talking about. It's interesting, he says, the reason why these are hidden treasures, secret deep, is because M52 is so close. People have always focused on M52, and they sweep right past these. Talks about this being like a spearhead shape. And then let's don't forget that up farther to the left here, there's another cloud. Let's see if we can bring our reds up a little bit and bring it a little bit closer into view. Here, up here. This is the LBN 540. So in our observation now, let's go ahead and say we can see an LBN 540 up left. see, NGC 7510 looks a bit like a spear head, and I'll give O'Meara the credit for having observed that. The cloud of NGC 7538 upper right has some dropouts on the northern edges. These are small but interesting targets. We can see why they are often overlooked. This starts our 98th observing session. So thanks for being with us, for many of you, for 98 sessions. Some of you have joined along the way. Again, you can kind of see from as we look past the scope, we're kind of looking up toward the celestial north. So you can see how the scope is pointing a little bit west of north. And sure enough, when we go over to Stellarium, if we kind of back away and kind of look, you can see here's the meridian, and there's Polaris. You can see how we're a little west of north. And backing off, you can see there's the horizon. Well, Papa Tech, that's great for you to encourage. We're just thankful that you guys are along, that's for sure. So we finished that observation. Let's head toward the next one now. Looking over here at our, let me go back and maybe pull this out a little bit so you can, here's our targeting software, Deep Sky Planner 8. And let's head to Secret Deep 104 next, and it's the Bruce Lee cluster. I don't know why it's been called the Bruce Lee cluster, but we'll slew to that right now, the Bruce Lee cluster, and then over here in SharpCap we'll just catch a picture of this before we lose it, and then we'll go back up under our sequencer and we'll say next target, and the next target name is NGC 7160. NGC 7160. And we go ahead and put that on our title here too. This is Secret Deep 104, otherwise known as NGC 7160. It's an open cluster in Cepheus. And what we've done there is given our mount some time to settle. We'll do a plate solve on this part of the sky, and welcome Footsteps for Jesus Christ, bride. Good to have you. Welcome. You guys remember what a plate solve is? We're kind of comparing what the scope is seeing live with what our mount thought it was. It should have been pointing at, and sometimes there's a discrepancy. In this case, it's our second target of the night, and it was about 1/4 of a degree off, 0.28 degrees off. So what it's doing now is aligning with its expected direction. And you can see it put this open cluster right in the middle of the frame. And this is a sequence. It's kind of like a little computer program. And it waits for 25 seconds for that all to set up. And then it starts live stacking, so we can see multiple frames stacked on top of one another, so to speak, for our actual target that we're observing. I was glad to get here a half an hour early tonight so I could shoot a new set of darks and a new set of flats. And we have those set into the scope tonight. You guys know what that does. The darks take out some of the, maybe the bad pixels, you know, that we might have to keep them from interrupting our view. And then the flats that gets rid of a lot of maybe any vignetting that we might have or any other aberration that we might have as a result of maybe improper alignment of our scope. And with the RASA, that's sometimes possible if you don't have the camera exactly aligned, just precisely. And ours is pretty close, but it helps to take those flats so you take out just a little bit of any aberration that you might have as a result of an improper alignment. Now this is actually lining up a lot better in terms of colors. You can see here that we can now set our black level here, and our mids we can start bringing up here. Put our whites way over here at the edge, and that is a super bright image for us tonight, isn't it? That's at 20 seconds at a gain of 100. I wonder if maybe there's been a change in sharp cap here. Frank, good to have you. Good to have you aboard, Frank. Let's do another color balance. Look at how bright that is, man. I wonder if I drop this gain down some. It's just kind of odd that there's so much luminance there, isn't there? I don't think I remember anything like this quite before. Such overexposure. I wonder if there's been some change in the way. This is a new version of sharp cap. We have stacking set on sigma clipping. Tell you what I think we'll do just for right now. Let's go ahead and take off live stacking and go back to real-time images just for a second. Okay, that's more like it. Let's just go at a gain of 100. We can see this cluster live anyway. We don't even need to stack it, do we? Look at that. This is Secret Deep 104. So we'll turn to this in the Stephen James O'Meara book. And this is sometimes called the swimming alligator or the Bruce Lee cluster. I don't see any alligator here. It belongs to the Cepheus OB2 Association, and it's an extended hydrogen alpha region, a H2 region. And it's a very young cluster, between 10 and 30 million years old. And oh, I wonder, oh, look, we just got bombed there with an airplane. So I'm interested in seeing what happens now when we take a new image. That airplane should completely disappear, you know, because we're not live stacking this live. So once we get a new exposure, that airplane should completely be gone. Yep, there it went. I wonder if the reason why this was brighter is because it's kind of in the middle of a nebula of illuminated gas, you think? Let's back our zoom off again, get a look at this. If this entire area is kind of illuminated, then you can see why when it was live stacking, it was kind of bright, where you auto-stretched in the main histogram. Well, let's check that out. You're talking about the display histogram? Let's reset that. That might have been it. I didn't do that, so maybe with the new image the new version of SharpCap, it actually done that. So Azray, that's a great thought. Let's just do imaging only here, and let that start live stacking. Just kind of curious as to what happens. Yeah, Azray, that was a good call. Good job. Okay, so now we're able to color balance and come away with a lot better it's still somewhat of a bright I didn't bother this display histogram. I don't ever do anything with it, so I have a hunch that with the new install of SharpCap, something triggered a new step up there in that upper right, up there where I'm wiggling my mouse in the display histogram. So if you guys have any other suggestions for me, I'm just resetting but not live stacking. There's that vertical band. Kind of get that up to a black level, huh? And that lets us bring this to a little more logical. Man, Azray, thanks for that call. It just shows the power of the team sport that electronically assisted astronomy is. Now we're about 80 seconds in on this cluster, and it's looking like it should have all along. So again, thanks, Azray. It reminded Stephen James O'Meara of a larger version of a Y-shaped asterism. Well, I don't know, guys. Do you see a Y in there? I'm not sure if it's... Has anyone here gotten a star named after them? Yeah, that's getting a star named after you is kind of in a way, you know, anybody could say they could name a star. And really the International Astronomical Union and the major star catalogs are not going to change their listings based on those businesses that do that. But I think it's kind of a romantic, you know, notion that some businesses have done. I guess anybody could name a star. I'm not seeing this Y thing. Anybody else seeing this Y that a dusting of dimmer stars surrounds the main Y stars? There's a triangle that looks like the head of an alligator in water. Excuse me. And talks about the scoots on the beast's inflated back. So do you kind of have to turn your head sideways, and here's the mouth of the alligator, I guess? So there's the alligator head, and these are the scoots. What's a scoot? The gator's eyes, these would be the two eyes of the gator. 2 7th magnitude suns have a warm hue. Let's do another color balance, see if we can warm them up a little. Oh, yeah, that might be warming them a little bit, huh? No Y for Mike. Same with me, Mike. I'm not seeing it, but I can almost imagine the gator a little bit better. So I guess that's it. The secret deep is, I guess, the fact that it's an alligator. The swimming alligator, he named it. 2,500 light years away. Let's add our observation here. We'll say, O'Meara saw the head of an alligator. Ricky says scoots are like the plates, scale-like things making up the outer skin. Ricky, you would know this because you're from Florida. So we're going to take you as the native down there. Interesting little cluster, not tightly packed. There's no real core, is there? Around 80 stars, O'Meara said. Now, as soon as I hit OK on this, the object disappears from our list in our targeting software. And so we can kind of save this. And then what we do is go for the next target. Now it says our disk is full, but it shouldn't be. I wonder what that's all about. Let's see, for our next target, at 41 degrees we have Secret Deep 20. So let's head over there. And you can see the scope moving. That's a live shot of the scope moving. Frank says you can make out the Y a bit better in the stellarium view. We should have gone there and looked at stellarium. We're going to open up stellarium here, have that ready. And this is now NGC 1807. So our sequence 1807. And then down here in the title, this is Secret Deep 20. Secret Deep 20, NGC 1807. And it's an open cluster in Taurus. The bull, huh? So the mount looks like it's settled. Now I'm kind of interested about this idea of the disk being full. So let's check that. I'm going to call up a take a look at our disk here. I'm using a new now it says there should be 285 gig free. I thought there should be free. So I wonder if Stellarium has introduced some kind of a new limitation in its options. And this might be something new to this version. I guess this is part of being on the bleeding edge. I always download the latest versions, so sure enough today I did. One of the things I noticed is down here in the live stacking options, with this version, today's version, which is version 4.0.9472, the raw frame stacking had defaulted to save stacked. So it was saving every single stacked frame by default, and I've never chosen that. It was just defaulted to on in the new version. So while this is stacking for a second, let's call up the settings and let's explore here. Oh, Mike has an asteroid named after him, 58364 Fireberg. That's awesome, Mike. SharpCap has detected an issue with your capture folder, which may not be valid, or your custom file name templates, which might allow capture files to be overwritten. Please check the File Name Settings tab, correct any problems. Yeah, see, this is all new. This had never happened before. So we're going to go to File Names. I think I saw the Y, but the end tail is curved like this Y, and if you rotate it, it'll look like an alligator. I don't know, he says. Excuse me, so trying to see, to avoid overwritten files, live stacked templates must contain total exposure, index, or stacked frames. You also need to include date, time. This is new. Let's see, sequence, live stack, stacked frames, frames, total exposure. I think there's some kind of an issue with this new version, because I'm not seeing any kind of limitation here, and there is plenty of space on the disk. So we're just going to assume that that's kind of an aberration. There are quite a bit of changes here in the see users right desktop SharpCap capture, so that's correct. Let's re-choose this. Yeah, that looks good. Just not seeing why SharpCap is being tricked. Boy, it's not letting me, to avoid possible overwritten files, live stacked templates must contain total exposure, index, or stacked frames. You also need to include date, time, or date and time. So he's kind of forcing us to a new file naming. Edit file name templates manually. Well, you know, the designer of SharpCap is famous for innovating, but tonight this is a little bit weird, isn't it? Just going to cancel out of that, and then we'll see if we can get by without this. So here's this amazing cluster here. Look at how rich this part of the star field is. But I think this cluster here in the middle is what we're after. Let's look at the deep sky image annotation. Let's do another plate solve only, and make sure that it finds this part of the sky, and that'll let us be able to mark this cluster a little more, with a little more exactness. So the plate solve succeeded. Now let's do that deep sky image annotation again, and there we go. So that happens sometimes. Sometimes you have to resolve so that you can sure enough find the object. And we're looking at 1807 right here in the middle. But look at this open cluster down here, 1817. So we're going to get a 2-for-1 special. This is Secret Deep 20, and this is Secret Deep 21. So let's go to 20 first. Secret Deep 20 and 20. You can see in Stephen James O'Meara's book, he does have the two clusters here on the same page, Secret Deep 20 and 21, and he shows the two pictures and kind of discusses them on the same page because you can see them in the same view. So the upper cluster here, which is NGC 1807, now we'll get rid of that. This upper cluster right here, he's nicknamed it Poor Man's Double Cluster. Oh, I see. These two are the Poor Man's Double Cluster. And 1807, 1817 are two intriguing patches of starlight in Taurus that form a visual double cluster at the northern tip of Orion's shield, William Herschel discovered the larger and fainter cluster, 1817, which is this one down here, Secret Deep 21, but he didn't notice the brighter and the smaller gathering of suns that is up here, 1807. His son John did discover it. 1807, which is up here, is brighter but less visually obtrusive because it only has 37 members and is just 12 minutes across, whereas 1817 has 280 members and is 20 minutes across. Tonight I have this really great little clip that I'm using, and this is saving my place in the book a little bit better than what I've had before. Sometimes when I've turned back to the laptop and I've gone to write something down in the observations, I lose my place in the book because the book kind of slams shut, you know, kind of loses place. So let's do a quick observation on 1807, which is the upper cluster, and you can say brighter but fewer members. Only around, what did he say, 37 members. That's probably the smallest cluster we've ever observed, huh? 37 members. And then we'll put in parentheses, NGC 1817 has 280 members and is more visually appealing, even though fainter. Okay, and then here's 1817. Okay, so it's great we can have kind of the 2-for-1 special here and save both. Look, an error has occurred while saving the image. So it just does not like this new file, this file naming routine that we originally used. It is not liking that at all, is it? So we're going to have to solve this file naming problem. Look at the way there's a difference in the way our color balancing is working, a difference in the way the side histogram, the display histogram is working. Okay, let's go solve this. For right now, since we're in the middle of a live stream, let's just go with his flow. So a process live stack. We're going to put curly brace target name, and then we're going to say stack number of frames, total exposure, and then we're going to put curly brace date and date and then curly brace time. I think it was sort of presumptuous of him to make us have to change these, don't you think? It's still not letting us click OK. To avoid possible overwritten files, live stack must contain. sequence stills. We still can't hit OK. What are we doing wrong now? Always because our date and time don't have curly braces. Boy. Remind me of the name of the programmer for SharpCap. I've forgotten his name off the top of my head. Well, another name is for tonight is just to don't edit the file names manually, and we'll just straighten out the file names later. I hope that saved it. Okay, so let's try it again here. Next target. And our next target is, let's go to Robin. That's right. Robin Glover, isn't it? Let's go to IC417. It's a cluster with nebulosity called the Spider in Auriga. So we're going to slew to that. And again, this is IC417. IC417. And down in our title, that is Secret Deep 22. Secret Deep 22. And it's IC417, I think it was. And it's an open cluster / nebula in Auriga, I think it is. And we're going to say, yes, it's settled. And now to do our plate solve. So, you know, Robin Glover is just trying to make this better for us. And I'm the one who takes the bleeding edge hit by upgrading without reading the release notes. And maybe from now on I'll have to take a lesson from this and read the release notes, because this file naming change that he made is significant enough that it threw us off. Okay, so IC417 is Secret Deep 22, and it's an emission nebula and a cluster. It's in Auriga, sure enough. William Herschel didn't find this, and he explains how to find this with binoculars. He says that there's a lot of nebulosity around this area. It looks like a patch of the Milky Way. There you go, right in the middle. There's emission nebula IC417 washing through this region, but he didn't expect to find this cluster in the middle of it. He said none of his star charts showed it. There was one nearby it, but not in the middle of it. Since I didn't see any cluster, I suspected that stock 8 must have been misplotted. So he found a mistake in the Millennium Star Atlas, and the actual cluster is stock 8. So now he's got my curiosity up. Does Stellarium have stock 8 or a cluster here? All right, let's get this sorted out. First, I'm going to hit reset up here in this display histogram. That's a new step to have to do. Now we're going to rebalance the colors. Having trouble. Maybe in a couple of stacks, a couple of frames, this will resolve better. Let's do one more reset up here. No, I think that's the best we'll get now. Moving this thing doesn't help us, does it? Oh, it does change it radically. I wonder if we're going to have to start using, in this version of SharpCap, which is 9417, I wonder if we're going to have to start using the display histogram first to try to seek a reasonable dark level with this sliding bar up there first. Then I wonder if we go down here, yeah, that's exactly what we're going to have to do, gang. It's kind of a new way to think about histogram adjustment in SharpCap. I've never messed with the display histogram. Now let's go over to Stellarium, and you know the way this works with Deep Sky Planner, we can just say right-click, show chart, and then the moment we go over to Stellarium, it has automatically aligned things for us. Now this is the Spider Nebula, and look how this region of nebulosity finds itself in a much larger region of nebulosity that is huge here. Now notice I don't have, in Stellarium, we don't have our field of view turned on for our RASA. Let me make sure this is correct now. 2600 RASA 11, yes. So this entire middle portion of the frame is illuminated. And look, we should be able to see another nebula down here at the bottom, I hope, called the Fly Nebula. That's interesting. Okay, let's compare that with what we're, yeah, right down here is the Fly Nebula. And then here in the middle is the Spider. So it's the Spider and the Fly. How about that? So what we want to do is intentionally dial up, now that we know that this area is filled with nebulosity, we want to intentionally dial this up so that we can see that nebulosity. Azray's asking, this is version 9472. Just downloaded this today, Azray. So you can see how there is an entire range of nebulosity around this cluster. And right in the middle is the cluster. Let's look at our deep sky image annotation. So we've got IC417, sure enough, here in the middle, and over here is NGC 1907, and down here is NGC 1931. So really our targeting software did us a good job, so we could see all three of these in one view. So IC417, yeah, 9268 is what I was using before as well, Azray, and I was not, you know, at all having to make these adjustments that I'm having to make tonight. This is a brand new feel. So let's just jot down here that NGC, I'm sorry, IC417 is the, I guess the hydrogen 2 ionized region. The cluster is stock 8 and is not identified in Stellarium, is it? No, I don't think the cluster is identified at all. To the left, in the same frame, same field of view, I guess I should say, we could see NGC 1907, another open cluster. And then at the bottom of our field of view, we could see NGC 1931 together with nebulosity there too, the Fly. And Azra is saying the flaming star is very close by. Stu, good to have you aboard. Tadpole Nebula is close, Stu is saying. Stu, we're using a new version of Stellarium, or a new version of SharpCap that has thrown us for a bit of a looper tonight. It's 4.0.9472. And 1758. Okay, so I think we're done with all those. Let's go back over to Stellarium one more time. Yeah, there's NGC 1907. And then the Spider Nebula here with, what is that? Phi Auriga, this star here, Hipparchus 25, 541, or 24 Auriga. That's magnitude 5. So that's probably part of what's lighting this up. Let's see if we can make a little more of this cluster somehow. Boy, that's certainly mixed in a lot more green. Let's bring down our green a little bit. You know, space doesn't have much green color, does it? Only in some planetary nebulae. So whenever you see green, odds are your color balance is probably a little bit off. But boy, bring on the reds, right? So all this area should be illuminated with that red, just like that. Now when we do that, at 9 minutes, we can see a lot more of the red of this nebula starting to come through. Antonio, yes, it's a SharpCap update. Stu, thanks, we've missed seeing you. Azray says the new version might be why the main histogram did auto stretch. Now you're calling the main histogram, you're calling that, this one up here, SharpCap calls it display histogram. I think you're right. Well, let's save this and see if it saves it this time. Yes. So by accepting the default save, we've lost the file name, but it at least did save it this time. It's the process version. Let's, one more time, just to satisfy my curiosity, let's go up here under File Names. And in the Process Live stack, can we try, oh, it's putting it under Processed. I I don't want it underprocessed. Can we just, now, can we pick those, we can't, can we? We can't pick those template names out of a template or something, can we? Target name. I wish that would be in front of all these. Stack, total exposure, curly brace, date, time, curly brace. Live stack. Why is it making me change the name? Because I don't save the live stacks. Auto save. Aha! I think we just were able to fix it. Okay, now we should be able to save it and it'll put the target name in front of it, which is the way I like it. So they're alphabetized by target name. Lucky Me asks, when is the big one going to hit Earth? If you're asking about asteroids, I don't think there are any that are in line to hit Earth right now. Green is the middle of the visible spectrum, so a green star would look white. Oh, good point, Mike. Yeah, the right display histogram. Correct. Okay, look at this view. I think this is starting to look a lot like our view in Stellarium, see? We're starting to see a lot more of this ionized region here. Okay, so let's call it at that. And in our targeting software, we've got, is this 23? Is that what we were just looking at? Yeah, 1931. So where was NGC 1931? NGC 1931, show chart. Oh, it is the Fly Nebula. So let's just say we could see NGC 1931, the Fly Nebula, in the same field of view as the Spider Nebula. I like this, the Spider and the Fly. And the Spider Nebula was, remind me, NGC or IC 417. Okay. What about a planetary nebula next? Looks very small, IC 2149, but let's try it. Just because it's on the secret deep list. So that's a live view of the scope. It didn't have to move much. This is still within Auriga, and it's IC 2149. Let's go up under here. IC 2149. I see, and this is secret deep 27. Secret deep 27 is IC 2149. 2149. And it's a planetary nebula in Auriga. Auriga is the charioteer, right? Okay, so the mount's settled. Some of these planetary nebulae in the secret deep list are so tiny. I mean, if you look in Stellarium, look how small this planetary nebula is going to be. It's just really tiny. Let's say, what its angular extent is? Yeah, 22 arc seconds. No wonder it's a secret, right? Yeah, Stu, thanks for helping us out. 22 arc seconds wide. I mean, like, that is like for a RASA, that's like the tiniest prize ever. Something tells me, oh, let me turn to this. So this is 27. And he says that it's 3,600 light years away. The charioteer, yes, named by Ptolemy in 2nd century. It's a peculiar little gem in northeastern Auriga. It was discovered by Williamina Patton Fleming, one of Harvard College Observatory's best-known woman astronomers in the world. While visually scanning the plates, she discovered new objects by means of their spectra. She was using an 8-inch refractor. She listed it as a gaseous nebula. Boy, are we going to be able to see this? An elliptical shell surrounding a ring. Well, let's see it. Let's try it. This is one of the more challenging objects, I think, for a RASA. Okay, remember the first step now in this new version is that we reset the display histogram first. Boy, that didn't help much. And then let's back off of our mids. And just for the sake of, so right there in the middle is where this planetary nebula should be. So that's apparently it. So look how it has two little tiny stars. Two little tiny stars there. But then let's look at the bigger arrangement. Here's a little triangle that kind of points above it. This is sort of a weird trapezoid, almost parallelogram, right? You have two brighter stars here and two wider space brighter stars here. Let's go over to Stellarium and take a look at this. So here's the top of the two parallelogram stars, and here's the bottom of the two parallelogram stars. We are looking in the right place, but man, this is a tiny, tiny target. But that's it right there. It almost just looks like a star that is like bloated, doesn't it? Oh, but look, we're starting to see a hollowed out portion. Now that's different because all the rest of these stars, you only see the white bloated dot. But with this particular dot, we're seeing a darker core. But see, we would never have recognized that, would we? You know what else is interesting? It's not circular. It's ellipsoidal. And more we're seeing that darker core. Let's reset this display histogram again, and let's try playing with this dark level. We move over there, things get lighter. Now let's do another color stretch. Boy. Probably the biggest telltale sign is that elliptical shape for us with a RASA. Let's see what Omira says. Oh, bipolar lobes. Look at that. We're barely seeing a little spur here on top. I don't know if you can see that on YouTube or not. But there's a little spur on top and a little spur right here. We are seeing that. Yeah, egg-shaped, Azray. That's a much better way of describing it. Egg-shaped. That's after 7 minutes. So we're going to say here, after just 7 minutes, we could see the egg-shaped nature of this planetary. And then I'm going to put in parentheses, as Ray, because you were the one who thought of that. We could also barely make out the bipolar spurs, lobes on the two poles. Huh. See if you can make the star swell with averted vision. Now with EAA, you don't ever have to use averted vision. Crank up the power. The nebula, the planetary nebula is high surface brightness. So go to the highest extreme. You can make it expand and contract by changing between averted and direct vision. You can see a bit of trivial fuzz around it. Perhaps even wondering why I would include such a visually lame object. He literally says that. Why would I include such a visually lame object? And he says one of the reasons is because the Royal Astronomical Society compares it with the final stage of life for our sun. He says, how lame and insignificant do you think that moment in our sun's life will appear to future backyard astronomers, those living on Earth-like planets that are orbiting lights that are 3,600 light years away? Would they think it a waste of time to search for such a visual trifle? In the grand scheme of things, just how significant are we? The answer may lie in your perception of IC 2149. Mike says, not lame. Omira sees IC 2149 as a metaphorical way of viewing our own sun's insignificant future. Deep thoughts, Stu says. IC 2149. Who would have imagined, right? Well, there's another planetary nebula let's go catch, but let's get our picture of this one first. Let's back off just a little until we can see less mosaic, just to kind of memorize that egg-shaped look. That's 11 minutes. Oh, it's so nice to have our file saving working again. You know, electronically assisted astronomy is just a series of technical challenges, isn't it? But I think if we stick to the challenges and keep trying to work through them, it can be very rewarding. This is an extremely small and difficult target, but I love what we've seen here tonight with it. So let's go to next target cycle. Go back to our targeting software, and let's show chart, so it'll set up Stellarium to show us where we are. And then let's go look at Secret Deep 25, which is NGC 2022. NGC 2022. And this is Secret Deep 25. NGC 2022, a planetary nebula in Orion. Orion. So looking over in Stellarium now. Kissing Crescents Nebula. So there's the part of the sky we are. It's kind of like almost southeast. Stu, it filtered out your comment at first, and then it said, do you want to show this? I had to click show it. Pretty sophisticated. So look at this portion of the sky. There's a lot of nebulosity here. Here's Betelgeuse. Let's look at the constellations real quick. Let's see. So this is the portion where we are. Here's the belt of Orion. Here's Betelgeuse. And there's Bellatrix. So the top two shoulders of Orion. And here's the Orion cluster. So about halfway there, between Betelgeuse and the Orion cluster, is where this Kissing Crescents Nebula is. Boy, I don't see how you tell that nebula from the regular nebulosity. NGC 2022. NGC 2022. So first, let's auto stretch this. Boy, that's just failing, isn't it? Now let's auto stretch down here. We need this to be blacker. Or do we? If it's in the middle of an entire, remember what Stellarium showed, this entire area is cloud. It's all hydrogen alpha cloud. So we just need to get it to be the right color. There we go. First observed by William Herschel on December 28, 1785, who described it as considerably bright, nearly round like a star with large diameter. It's an ill-defined planetary nebula. You think that's our planetary nebula right in the middle? I bet it is. So much nebulosity here. How would we have ever noticed this planetary? Let's bring our mids down so it doesn't accentuate that nebulosity quite as much for the purposes of observing this planetary. And let's just focus on the planetary. We're starting to see a little bit of a hollowed out core. That would be our first tip, right? How could he tell 350 years ago, Stu says? Great question. Hubble has a classy photo of it. Okay, so it's NGC 2022. NGC 2022. NGC 2022 ESA Hubble. Wow. So that's the planetary we're observing if we just had Hubble out of the backyard instead of an 11-inch RASA. What was I thinking? We should have just, you know, my feet are really getting cold in here. Fortunately, because we're inside an office, I can just dial up a little bit of heat here for us. How about that? I've got a little space heater here at my feet. I like the Hubble view better than the RASA 11 view. Hits our eyes. Okay, so this is 25. This is the Kissing Crescents Nebula. How did he ever find this? Stephen James O'Meara recounts the first time he saw this. And he talks about how it stood out from the stars around it. It's a prolate spheroid, like an American football, surrounded by an almost spherical, fainter shell of matter. Okay, we're starting to see a little bit of that by dropping our mids all the way down here. And that's after just 7 minutes of integration. And remember how much nebulosity there is in this part of the sky? So what we've done is we've defined a new black level that's equal to that nebulosity. And that's letting us pick out this planetary nebula from all that noisy background of nebulosity because of the new black level point we've defined. We've said, let's pretend that we couldn't see all that nebulosity. Let's just pretend like it's black. What would this planetary nebula look like if it were hovering on top of it? And there you go. I love EAA so much. So there's that core we're starting to see at just 7 minutes and 40 seconds. How did you fix the files, Azray asks. I kept playing around with the demands of the new version of SharpCap. It had in red print there, you gotta have this, and you gotta have that, and you gotta have this. And once I got one that felt like I had all that, I started pasting it in everything. And suddenly the OK button lit up. So I must have satisfied its picky nature. Stu says, when I made the comment about wishing I had a Hubble instead of a RASA, Stu says, laugh out loud, time to upgrade, Doug. A Hubble wouldn't cost too much more, surely. Tommy Kessler says, yo. Hello, Tommy. Stu says they're talking about updating the JWST, this new Carl Sagan Space Telescope. If you zoom way in on Stellarium, you can see it better. Let's go over to Stellarium. and zoom way in. Ah, you're right, Azray. Stu says I have to go get fish and chips, or as we call it in New Zealand, fish and chops. Huh. Well, Stu, you're kind of making us a little hungry. Well, Azray, thanks for alerting us to this. This is a beautiful version. So look at the egg inside and the halo outside. And see, we're just barely starting to see the egg inside and the halo outside. 9 minutes and 40 seconds. I'm just not going to lie, I'm a big fan of EAA. If you guys didn't know that already. After just 9 minutes, we could already see the American football-like core, O'Meara, with that fuzzy halo around it, even though this object was tiny and pasted on top all that noise of the nebula. EAA rocks. All right, let's be on our way here, gang, to the next target. And let's see, we've seen several clusters. Let's go look at a galaxy. This is Secret Deep 8, NGC 1084. So we'll slew there. This is NGC 1084. And again, it's Secret Deep 8. Secret Deep 8. NGC 1084, a galaxy in Eridanus, is that what that's called? I'm sure I'll probably have to change the spelling on that later. This is Secret Deep 8. Eridanus, no, that's right. And I'm really liking my new, this is definitely an important accessory to have for EAA if you're using a book like this, to be able to hold the book and keep it from flopping closed on you. Look at that satellite right in the middle, making its way across. Secret Deep 8. Jeff Bowerbank. Jeff, thanks so much for welcoming us back. It's very kind of you. Yes, we had a trip out of town to a convention and a couple of conferences, and also I got laryngitis. A cold settled in my throat. Ooh, look at this galaxy right in the middle now. You can already see it. NGC 2022. Did NGC today? Yes. It's our first galaxy tonight. So I got through the laryngitis. Okay, so remember our first step with this version is now we have to reset the display histogram with a click. And actually our color balance isn't terrible down here, but now we're bringing up our mids from how low we had them on that planetary nebula. And look how the galaxy comes into view just like a bird of prey, a Vulcan bird of prey. There goes another satellite or two. This is a beautiful little galaxy. It's just so tiny. Man, I'm really loving this new flats. New flat correction frame. It's a beautiful little galaxy, isn't it? That's just after 80 seconds. Wow. I don't think my eyes would have ever seen this galaxy in a million years. Let's read about it. Secret Deep 8, NGC 1084. It's 3 arc minutes long and just under 2 arc minutes wide. Do not be fooled by NGC 1084's magnitude, which is 10.7. It is a small but obvious galaxy, 3 degrees northwest of 4th magnitude, Eta Eridani. And the name of that star is Asha. Asha. It's very visible in a small telescope, being highly condensed, making it an excellent target for suburban observers. Okay, points out there are several galaxies in this region. It looks like a late type spiral, receding, going away from us at 1,500 kilometers per second. Has a small central nucleus compared to its main massive spiral arms. Now that's 260%, well into what we might call the digital zoom. But I think you can still see a little bit of the structure there, huh? It's moderately sized, about 56,000 light years in its longest extent, inclined at 63 degrees from face on. Has a total mass of 50 billion suns. No sign of a bar. Not going to be able to get any alcoholic drinks in this galaxy. Star formation regions. There's a spur in the northeast. Lots of unusual gas motions around it. Intergalactic clouds, or a dwarf galaxy that's interacted with it. Small island of hydrogen alpha emissions. Tells how to find it. Where to sweep. pretty much need a 5-inch. Wonder if his 5-inch was a refractor. And a 5-inch, it looks like a conspicuous egg. It's a great galaxy to watch for supernovae. 4 known to date. 4 supernovae in the last half century. NGC 1245. Very cool. Small but well-defined spiral around 56, I think it was, 56,000 light years across. Omiron. Bright. Amazing. You know, these are objects that we would never have sought out, right? You know, almost everybody that you encounter on the web or, you know, at a star party, they're all showing you Andromeda, you know. Nobody picks out these 2 arc-minute wide galaxies to go look at. Only if you have a book like this that kind of dares you to try it. And especially, nobody would ever tackle this with a RASA that has a field of view that's so wide. I mean, our field of view is like, what, 2 degrees and change by 1.5 degrees. So look at that field of view and just think, we would never have tackled this if it weren't for this book. It's only because we're working through this book. All right, so how about if we go to a diffuse nebula now in Orion? It's Secret Deep 26. Secret Deep 26. Show chart. Flew to it. It doesn't have an NGC name, in fact. It's SH2 276. SH2 276. That's Secret Deep 26. 26. SH2-276. A diffuse nebula in Orion. Certainly not visible there yet, huh? But that could be, it's because we're not quite on track. You're right, it was a complete degree off. I bet we must have crossed the meridian. And so we were a full degree off. But with plate solving, we'll find it, right? 26. Herschel's region 27. This is a great drawing of it. He doesn't really label it as 26. Instead, he points at it as Herschel's region 27. So there's the belt, and right there is the target. Excuse me. So first we reset the display histogram. Boy, I don't see this. Huh. Right there. Right here in the middle. Let's go over to Stellarium and look at it. Barnard's Loop. NGC 2112. Herschel's region 27. SH2 276. It looks like it's in a different place, doesn't it? Herschel's region 27. Doesn't look like we're in the right place, does it? Looks like that's Barnard's Loop. Oh yeah, look. Barnard's Loop is correct. SH2 276. Is Barnard's Loop the cluster? Oh, so sorry, Stu. Thanks. So sorry. Why are you just seeing me? Hopefully that'll be fixed now. Is Barnard's Loop the cluster, or is Barnard's Loop... It should be a nebula, shouldn't it? Shouldn't Barnard's Loop be out here? Isn't this where Barnard's Loop is? Or is Barnard's Loop in here? SH2 276. Well, there's no artwork at all in Stellarium, so we can't hope for anything there, can we? dial up this green side, and now dial down the red. I guess there's just an underlying... You're looking good, Doug, but show us the sky. I don't want you to have to look at me, thanks to... Is Barnard's Loop just all this nebulosity? Let's go out to the web. Shield your eyes for a second. And say SH2276 Wiki. Barnard's Loop. Wow. Wow. Are we just looking at one little tiny piece of it? How big is Barnard's Loop? Let's go back. How many degrees does it? It's a cloud complex which also contains the Horsehead and the Bright Orion Nebula. Takes the form of a large arc centered approximately on Orion. 600 arc minutes. Okay, 60 arc minutes would be a degree. So is this 10 degrees wide? (518 light years away), 100 to 300 light years across. It originated in a supernova explosion about 2 million years ago. So I don't know what this is even going to look like. Part of Barnard's Loop, the brightest segment. So it's a supernova remnant. It cuts through most of the length of Orion, I see. It's giant. It's 10 degrees by 5 degrees. And just for the sake of understanding our field of view, this is all part of Barnard's Loop. That's weird, isn't it? So you're after the brightest telescopic region. The legendary visual observer and photographic genius Edward Emerson Barnard was not the first to discover it. Talks about Barnard telling the story and then working backward. Region 27 is one of several areas of the sky that William Herschel lists as being affected with milky nebulosity. Nobody was convinced at first. just a subtle glow that is best seen with a slow and generous sweep. It's best to start at 60 Orionis and then sweep slowly toward M78. Tackle it bit by bit. One of the problems we have is that since we can't see it all, we don't know what it should look like in our frame, right? So for example, see all that cloudiness? There's just a general amount of cloudiness there. But it's not like one particular zone of cloudiness so it stands out against a black night sky. The whole thing looks cloudy, right? I guess at this point, you're starting to see it a little more cloudiness here, right? Like that. Just general nebulosity. A diffuse nebula. It's a good name for it. Diffuse nebula. One of the challenges of observing Barnard's loop is that we don't have a clear-minded benchmark in the same frame of what black is supposed to look like. But it is kind of cool, isn't it? All that red cloudiness. Well, let's go to one last object, and that's the cosmic bat. Secret Deep 19. Yep, reddish glow. Mike, you're right. This will be our last object. Thanks to everybody for staying up with us. We've still got over a dozen with us. Don't forget, if you like content like this, it helps if you subscribe, because that way other people will see the NGC 1788. NGC 1788. Other people will see the content a lot more in their heads-up display if you go ahead and subscribe or click the thumbs up. This is Secret Deep 19, otherwise known as NGC 1788, a diffuse nebula in Orion. Also, we do have a Patreon site now, and that just came at the request of several observers who said, can we get some Emerald Hill Skies merchandise? And that Patreon site can be found at patreon.com/Emerald Hill Skies. So feel free to check that out. You can always go to emeraldhillskies.com, the website, and subscribe to an email newsletter there, and that way you get an email alert, usually 24 to 12 hours before we do a live stream, sometimes 48, but at least 12 to 24 hours before, you'll get an email alert. And also at that website you can learn more about our observatory, and you can also see a little more about the lists that we're using these days. The Herschel 400, the, let's see, the Secret Deep, and also the, it's been so long since, you can go to Resources, and Secret Deep, the Hidden Treasures, the Caldwell list, and Herschel 400. Those are the 4 lists that we're working on these days. Wow, so this nebula shows up right at the beginning. Let's do this reset here, and then let's color balance one more time. Let's give ourselves a little bit. Bring up the reds there, so they'll be all matched. Let's put our blacks right about there, and bring our mids around there. And there is, in a Secret Deep 19, NGC 1788, it's this cluster and nebulosity here in the middle. If you're a regular visitor, you know that we use electronically-assisted astronomy, which relies on stacking one exposure after another. Our exposures are 20 seconds with a gain of 100. And thanks to these exposures, average out the noise. I don't know if you can see, but here around this nebula, there's a lot of sandy, kind of grainy looking stuff, and that's just pure noise generated by atmospheric light pollution and different kinds of artifacts in the electronics, so to speak. So with live stacking, it averages out the parts that change in every exposure, and it keeps dialing up the parts that are illuminated in every exposure. And that's part of what gives us this, you know, these kind of amazing views, is because we can set our black level on something that darkens out all that noise because of these 3 minutes worth of live stack. We have 9 different subframes, 20 seconds each, and already we can see this nebulosity that is Secret Deep 19. So I'll just close by reading just a little bit more about Secret Deep 19, the Cosmic Bat. It's the Fox Face Nebula, a reflection nebula in Orion. It's chock full of deep sky wonders, Stephen James O'Meara writes. He talks about the ones we all know about, but this NGC 1788 didn't make the Messier list. It didn't make the Hidden Treasures list, but it made the Secret Deep list. Again, the Secret Deep list. It's a lot of hot and young shock waves that are expanding out from several supernovae explosions, compressing the cold material of giant molecular clouds, squeezing the cores, and then collapsing the cloud due to self-gravity, forming embryonic protostars. And ignites this core reaction that burns hydrogen into helium. Wow. And it's formed these isolated molecular clouds that are far from the massive complexes that we're used to seeing. Instead, you get this energy that's streaming from the bright, massive stars. An average age of just 1 million years. It's a small but pleasing reflection nebula. He says, if you look carefully, there's a larger halo around it. Let's see if we can illuminate that larger halo a little bit more. See the halo? Again, that's just by boosting up the mids a little bit after just 5 minutes and 40 seconds. Well, if you can't tell already, we are fascinated by electronically assisted astronomy here at Emerald Hill Skies, and we love chasing after molecular cloud with ionizing stars, fairly bright, multicolored, satisfying object. It's amazing. NGC 1788, Secret Deep 19, another treasure in Orion. Well, let's close on that one, folks. Thanks again for joining us here at Emerald Hill Skies. We do this about once a week when we're not traveling or when we don't have laryngitis. And I hope you'll stop back by. We'll send out an email. We post in the YouTube channel a post that there's a live stream coming. We prepare the live stream so you can see it coming, and we always love having live folks. Azray, thanks for showing us this faint objects. See, nice variety of objects tonight, none of them lame. That's good, Mike. All right, we'll hang it up with that. Thanks again for being a part of this. We appreciate you because you were watching live or even the recorded version. We hope you stop back by Emerald Hill Skies. Thanks especially to God for making all these amazing objects like the ones that you see right now on the screen and all the ones we've looked at tonight. God bless. Have a great evening, and we'll see you again on Emerald Hill Skies. Good night.